Hi students. Um, I created you an assessment on similarity and congruence. So what is important there? I want you to study this definition of similarity. Of course, these keywords are also very important. You did, now we didn't do this exercise, but here you have a good example of what similarity is. Similarity is not necessarily the same size, but the shapes must be the same. Okay, then when we page over, they explain similarity to you in calculations. And on this page, here they talk about two triangles or two shapes, quadrilaterals if you want, will be similar if their sides are in ratio. If you will look now, if you will see how they explain it to you. If I put 9 over 6 and I simplify it, I get 3 over 2 because I divide it by 2, by 3. If I put 15 over 10, I will get 3 over 2 again if I divide by 5. So therefore, these two shapes are similar because they are of the same ratio. There they showed you. There they tell you. If you put the one side over the other one, it creates a fraction. Or you can put it next to each other, 12, and then the semicolon, after colon, 12 to 8, and you simplify by 4, you'll get 3 to 2. So this is what they are telling you here, that when they give you the lengths of the sides, and you can put those sides in ratio. In other words, you take the one, you put it over the other one like in a fraction, and you simplify, and you get a simplified fraction. You do the same with that side and that one, and you simplify, and you get the same answer as with these two sides, and you do it with that one, and in the end, this one with that one. In other words, you create 4 fractions with the one side over the other one, and all 4 answers are the same. Then the two quadrilaterals or triangles are in the same ratio, therefore they will be similar. Here they show you the same. You see, here we can see they are creating fractions. And then they do algebra. And then they will, here they find the side. Don't worry as much about this example. Don't worry as much. This one is more important, where they calculate the ratio. Okay, and then on the next page, we start congruency. Now, congruency is what is most important, same size and shape. Everything must be the same. These two shapes must be like identical twins. I can almost say they must be the same color, they must be the same size, everything about them must be the same, then they will be congruent. Whereas similar, look here, we have two shapes, they are similar, that means they more or less look alike. They're not twins because this oukie is bigger than that one. But with congruency, yeah, these two are exactly the same. If I cut this one out and I put it on top of that one, it will fit perfectly. The same with these two and the same with those two marks. Even though they don't lie the same way around, doesn't matter. If you turn it around, you rotate it and it fits exactly on the other one. And even if you close it like with a book, put the other one on the one on the other one, then they will fit perfectly. And that is what we call congruency. There they say, the same size and shape. That is the most important thing that you have to remember about congruency. And then on page 66 is an exercise that you can just do for yourself. See if you can recognize similar. That one and that one, these two are similar, for instance. They're not the same size, but they are both pentagons. So see if you can do that exercise for yourself, and find similar shapes. Then on the next page, very, very, very important. We are talking, in the previous lesson, I spoke about the postulates or the laws or the rules of congruency. Students, you have to know these. These short abbreviations, triple S, stands for all three sides are equal. Then we have SAS. That means there's a side. Let's see on this picture. There's a side. There's the side. There's another side, and the angle that is caught in between. Let me take the pencil. It's better than my finger. There's the side. There's the other side, and that angle caught in between, that is SAS. Side, angle, side. And if the same happens on the other triangle, there we have side, angle, side. Then we say by the rule of SAS, these two triangles are congruent. The next rule we have here is the AAS rule. That means it stands for angle, angle, side. So that means any two angles and a side. Then we have congruency. Then this one, we have the RHS rule. Now the R stands for that right angle. You can't use RHS in congruency if you don't have a right angled triangle. So the right angle must be there. And then 1, the H stands for the hypotenuse. The hypotenuse is that long side opposite the right angle. Remember, sides and angles are in relationship with one another. 90 being the biggest angle in the triangle, so therefore that side opposing it, opposite it, will be then the longer side, which is called the hypotenuse. That's what the H stands for. And then the S means a shorter side, one of the other sides. It might be this one, but then it must be that one in that triangle also. In this case, it is this longer one is equal to this longer one. The hypotenuse is equal, given, because they give it to me. And of course, there's the right angle. So this is how I can say that these two triangles are congruent. But again, students, you must please know this. If I come back to school and I talk about triple S, you must immediately tell me, ma'am, 3 sides. If I talk about SAS, we somewhat call it SAS, you must tell me, ma'am, side, angle, side. If I say AAS, you say, ma'am, angle, angle, side. If I say RHS, you must say, ma'am, that is in a right angle triangle. It's the hypotenuse and one of the shorter sides. Okay, then I asked you the last time to do this exercise 5.8 for me. And then, of course, these keywords. Students, study this, really study this. If you know this, you more or less know all the work. And then today we're going to talk a little bit about the circles. You must know the different sections of the circle. There we have the diameter. Diameter cuts the circle in half, of course. Circumference is the outer rounding of the circles. That means if I walk around the circle and I measure, I start here and I measure, I will come back and I will have so many centimeters or meters or whatever unit they gave me. So circumference. Then sector is this pizza slice. Sector is the pizza slice. Remember it like that. Now the sector is shaped by the radius. See, there's the center, there's the radius, and there's another radius. And then there's the arc. Remember the arc that we do with our compasses? Right. So that portion between 2 radii, and it is connected with the arc, I call a sector. Right. There's the radius we mentioned there, and there's the center. And at the bottom, they talk about a segment. Now, a segment is created when we have a chord. Now, how do I know what a chord is? Yeah, in the keywords, they tell you. A chord is a line joining 2 points on the circumference of a circle. Right, let's go back here. A line that connects 2 points on the circumference of the circle. So C is a point on the circumference, D is a point on the circumference, and the chord is a straight line that join these two. Now this piece here in between, now there's the arc on the outside. If I enclose this inner part, if I color this in, that is what we call a segment. Now, if you go back to a science or life sciences, they will also talk about a segment. A segment is a part of. So this is also what a segment is. Then I want you to do exercise 5.9 for me. Look at that circle. Refer back here if you get stuck. Look at these numbers that they gave you. Remember, we name lines and line segments by ZO or OY or OX or whatever. And then when you have to show me the diameter, now which line is the diameter? There is a line, there is a line, and there's this line. Which of those three is the diameter? So you name it. Is it Z, Y? Is it OX? Is it OY? Or is it XY? You must know. So this is how you do that one. Right? And then you just answer number 2 and number 3. And then number 4, this is almost like a family tree. A circle has these different sections, and now you have to describe what is the circumference. So you can take your book, your exercise book, and when you do this, turn the book then like sideways. Do you understand? Turn the book sideways so that you have enough width to create this family tree. Let's call it the family tree of the circle. So here you just tell me what the circumference is, what the diameter is, what the radii is, what the center or where the center of the circle is, and what an arc is. Now here they give you, isn't this nice? Here they give you all the definitions. So you just take the sentence and then you write it in there. A line that forms the circle. Right, which one would that be? I'm just going to help you with the first one. A line that forms the circle. That would be the circumference. Because if I draw a circle, there it is. There I draw the circle. There it is. I draw a circle. I have done the circumference. So the first one is a line that forms the circle is of course the circumference. So then you can do that exercise for me. Okay, and then we can page over to revision. Again, revision, you can do that for me also, that is easy. Number 1, 2, and 3, you can understand by yourself. Number 4, they give you 3 angles of a shape, of a quadrilateral. Find the 4th one. You should be able to do this because we have already determined the theorems of what is the inner total of the angles of a triangle that adds up to certain degrees, and the inner angles of quadrilaterals add up to a certain degree. You have done that when you did this exercise. Let me get the page. It is on page 59. There it is. Yeah. If you did this, it will be easy for you to do this exercise. Right, and then number 5, just find me the congruent shapes. A and does A have a congruent match here? Now I'm going to help you with this one. A does not have a congruent match, but A and P are similar. They're not the same size. If you look at it, you will see they are not the same size. And remember, what are congruent? congruent are like identical twins. They have to be of the exact same size. So A and P are not congruent. They are similar. All right. And then on number 7, look at these two triangles. Tell me if they are congruent and give me a reason for your answer. Now, what is the reason? Now you will say, ma'am, SSS.